Hi everyone, welcome to STEMbrarians week 2. This week we're going to be doing a little bit of rainbow research. So in honor of kind of St. Patrick's Day coming up, and just because spring is here, there's going to be a lot of rain, and hopefully that means there will be a lot of rainbows. So today we are going to try to learn, can color travel? So what do you guys think? Well, let's learn some background information first.
So, first off, what is a rainbow? Well, a rainbow is a multicolored arc made when light strikes water droplets. It's the light being refracted and reflected by the water. So, light is refracted or bent as it enters the water droplet. It is then reflected and bounced off. Sort of like this image, how it shows it hitting the prism and then bouncing off. As it exits the reflected area, it's refracted again. And that's why the red is the longest reflection for the wavelength, and the purple is the shortest. Moving on, our hypothesis. Knowing all of this, how do we think we can make color move? Well, you can't just move it on your own. We either need light, or let's try something called chromatography. Chromatography is basically when things get separated, especially chemicals. So chromatography is used in laboratories a lot for analysis and purification. And it's actually one of the biggest components of small and large-scale production. And it's used a lot by artists and color theorists who want to try to dye textiles to make them different colors. They use chromatography to see how the colors mix and blend or how they separate, and that way they can get the color they're looking for. So it's pretty interesting to see how both science and art kind of go hand in hand. But let's get back to trying to make this rainbow.
So remember that while we get ready with our supplies. So to make a rainbow, I'm sure you guys mostly know, there are a lot of different colors. So we have with us red, orange, yellow, green, blue, and purple in washable markers. Also have those same colors, red, orange, yellow, green, blue, purple, in permanent markers. And then for a little bonus experiment later, we also do have red, yellow, and blue food coloring. We'll get to that later. But we also need, for our supplies, some paper towels. I have 4 paper towels folded in half. And then I have 6 regular strips of paper towel kind of cut into little, like maybe 2-inch by 7-inch long. Doesn't really matter so much that, but just 6 pieces of paper towel. And then we also have water. Don't drink any of your experiments. You never know what is actually inside, because this is water, and this in a clear cup could also be water, but it's actually not. It's rubbing alcohol. So always be safe. But I think we should get started with our first experiment. And so our first experiment is so to test our experiment, we are going to start with one of our folded pieces of paper, and we are going to color a beautiful little rainbow on it. Now we are going to start with the Crayola Red. Can be any brand, but as long as they're washable. And you're just going to color. And I'll show you guys a little close-up. You're just going to color a strip just like that. And once you do that, you're going to make sure it's nice and dark and saturated, because we are going to be seeing if the chromatography works with these markers. So you're going to do that for all the colors, a nice little strip. So I'll just fast forward through this part here. Okay, so like I said, you want to make it nice and saturated. Make sure it is very kind of even on the end, so we have a clear start and end of where our rainbow is, and you want to make them about all the same width, just like that. So once you do that on the one side, you're going to do the same thing on the other side with the same markers. So with the washable markers, you're going to just repeat that process. So let's speed this up. voila, you have your matching colored rainbow on either side. You want to go about a third of the way in on both sides, so that way you have a third left in the middle, and this is hopefully where our rainbow will kind of bridge together and join. So we're going to leave that to the side because we are also going to make another paper rainbow with our Sharpie markers. So remember, our first experiment is to see what can dissolve in what. So we're going to do the same thing here, but with the Sharpie. And again, you just want to go a third of the way, make it nice and saturated. And you want to just be a little careful with the Sharpies. Sharpies can stain, so just be careful that you are doing it on like a paper towel or on some newspaper or on a piece of furniture that your parents won't get mad if you get a little Sharpie on. The good news is I do have a tip to get Sharpie out. I'll give you guys at the end of this in case you happen to get a little bit of Sharpie somewhere. All right, so just like we did before, lots of nice bold strokes for these colors. Now, you don't want to press too hard because you don't want to rip your paper towel. But like I said, you do want to make it dark. And for those of you at home who might be wondering, the reason I am using a light purple is because the dark purple kind of looks a little too close to the blue. It's a little hard to see. But anyway, we have our one side of our Sharpie rainbow done, and we will now do the same on the other side. So let's just skip ahead. Okay, so as you guys can see, I now have my Sharpie rainbow done. So I'm going to keep my Sharpie rainbow on this side and keep my Crayola rainbow on this side. As you can see, they both look pretty similar. And now we are going to test our first experiment. So our first experiment is to see how well these colors dissolve. So remember we talked about how chromatography is used to kind of dissolve and separate. So we're going to see if our water can dissolve these colors. So this is the Sharpie side again, and this is the regular washable Crayola side. So I'm going to put both in and let's see what happens. So again, this is the Sharpie side. I'm just going to push that in so it gets nice and saturated. And we're going to push in this side so it gets nice and saturated. So I have another camera here in case you haven't noticed, just to kind of see, you guys can get a better view of our rainbows. So I'm going to just angle it so we can see who is moving a little quicker or not. And actually, you can already see in here, this rainbow is moving, whereas this one isn't doing much just yet. As you can see, the water too is a little bit more pigmented on the washable marker side, which means there is a little bit of runoff into the cup. But if you look closely, and I'll zoom you guys in on this side so you can see, the colors of the markers are moving to connect the bridge. Our rainbow has met in the middle. Look at this, guys. Our color is still on our ends, but it has crossed the bridge to the middle. And like I said, we do have some runoff in our cups, but it's not too bad. And on this side here, we don't have really anything. No rainbow, no movement, just a little discoloration in there. So we've learned that because the water in the water-based markers is attracted, it helps it dissolve and separate, which makes the rainbow move on the paper towel. Pretty cool, right? All right, well, let's see if we can try this again. But instead of using water for the Sharpies, what if we tried something different? What are some options that we could maybe do? Think about that while I color another rainbow. Phew, that was hard work. All right, we have another Sharpie rainbow. So as you guys can see now, I have two different liquids, and this is what I was telling you before, is rubbing alcohol. It's a little discolored, but we're just gonna disregard that. Anyway, we have our Sharpie based strip of rainbow paper there. And I'm going to quickly color a regular washable Crayola strip. Alright, so here is my Crayola markers. Now since that one worked last time, let's just start with that one. So let's see, if I put my Crayola markers in here, I'm gonna move them a little closer. I'll show you guys here so you can see. Doesn't really look like anything's happening. Let's give it a minute. Alright, we're back. Doesn't really look like anything happened. Our rainbow did not move when we put the Crayola washable markers in the rubbing alcohol. But let's see if we try putting the Sharpie permanent markers in rubbing alcohol. So if we put them in here, and again, I'll put it here so you guys can see a little better. Let's give it a few minutes to soak up all those good juices and see if anything happens. Alright, so as you guys can see, it is building a slight rainbow. Now it is a little bit slower than our friend Crayola washable markers, but as you can see, there is a process happening with the alcohol and the permanent markers.
So what did we learn for that? What are some of our observations? Did the washable markers dissolve in the water or the alcohol? Right, you guys saw it. It was the water. And the permanent markers didn't dissolve in the water, but they dissolved in alcohol. And which markers made the rainbow quicker? So you guys can try all of these questions at home, but let's get back to our experiment.
So that is something good to know, is that permanent marker dissolves in alcohol. So if you ever get some permanent marker on a hard surface, you can usually 9 out of 10 times get it out with a little bit of rubbing alcohol, as long as it's not something that'll be damaged by rubbing alcohol. So double check with your parents before you do anything like that. But we're gonna let this guy keep doing its thing over here to the side. And while it's doing that, we're gonna start our bonus experiment, because that takes a little bit of time too.
All right, it's time for the bonus experiment. So if stationary color can travel, what about liquid color? Let's see if we can make a walking rainbow.
So we have 1, 2, 3, 4, 5, 6, and 7 cups. So I'm just gonna push these guys to the side and move down my little train. So we learned that color can travel, right? But only in certain circumstances. If it's water-based and it's in water, the chemicals separate properly and it's able to move. And we learned if it's alcohol-based, like a permanent marker, it dissolves in its own chemical. So, what would that mean if we changed our question? Instead of can color travel, which we now know, can a rainbow run? Now you may be thinking, Miss Alex, how could a rainbow run? Well, I'm going to show you guys. So before we were using the stationery, the paper towel as our stationery, and the water was our liquid. So the stationary color was dissolving into the water liquid. Now let's see if we made liquid color to dissolve into the stationery. So this is where we bring in our friends red, yellow, and blue food coloring. So we learned a little bit about rainbows, we learned about refracting, we learned about chromatography, and a bunch of other cool color things. So let's see if we know how to mix colors. So I have here some red food dye. I'm just gonna do a little drop in here, if I can get it. There we go, a red drop there. And we're gonna do a red drop here. There we go. I'll do another drop here because that other one wasn't so great. All right, so we've got red food coloring on each end of our little rainbow area. Now I'm going to do a drop of yellow into that one. And I accidentally dropped a drop, so it's slightly tinted already. But I'm also going to drop a drop of blue into this one. So every other one is going to have a color. So we have red, yellow, blue, and red again. Now you may be thinking, Miss Alex, that doesn't look like a rainbow. You showed us the rainbow. There's a bunch of colors. There's yellow, blue, and green, and purple, red, and orange. So why do you only have 3 colors and not 6? Well, my friends, we know about chromatography is separating of mixtures and chemicals. But what about if we combine things? So we're going to try to combine these colors by making our rainbow walk. So by doing that, we're going to take our little pieces of paper towel we had, fold it in half, like so. And I'm going to connect each one of these with a folded paper towel. And we're going to see if we can make our rainbow run. So I'm going to start here on this end. So, as you guys can see, it is doing its thing. It might take a little bit. Bear with me while we wait. In the meantime, we can take a look at our alcohol-based rainbow. And you guys can see it's a lot closer than it was before, which is pretty cool. So, we're going to put that off to the side for now. And now, we play the waiting game. All right, we're back. Sorry that took some time. But as you guys can see, our papers are saturated so much so that they transferred the color into the other cups. So I'm just going to pull all of these out so you can see. So as you guys can see, our paper towels are still the colors of the original colors: red, yellow, blue, purple. I'm sorry, red, yellow, and blue. But because of the mixing of colors, because of primary and secondary colors, we have now a full rainbow: red, orange, yellow, green, blue, purple, and then red again. So it's pretty neat to see how both mixing colors and separating colors can make things travel and make a rainbow, right? We've learned that with rain and the reflection of the sun, we get rainbows. We've learned with markers and chemicals dissolving and separating, we can get a rainbow. And we learned by adding color, we can also get a rainbow. So there's a lot of different ways to make rainbows, and there's a lot of different ways to make rainbows move or travel, or in this case, run. So hopefully you guys enjoyed these little rainbow research experiments. Hopefully you guys will get to see a rainbow soon, and maybe even a pot of gold at the end of it if you're lucky. But we hope you guys join us next week for more STEMbrarians fun, and we see you soon.